Hi and welcome to yet another episode of Casted. Our guest today is Felienne Hermans from Amsterdam, the author of The Programmer's Brain, What Every Programmer Should Know About Cognition. So today will be maybe slightly more technical than usual because we will talk a lot about programming and software development, but there's also a lot of interesting stuff about learning and teaching and knowing how to know things and basic cognitive science. So I think most people will get a lot out of that. Felienne, hi and welcome to the show.
Thanks for having me today.
Excellent. So let's go. There are many ways of explaining this, but let's go back in time to little Felienne who just learned programming. So how was that for you? How and when did you learn to program?
Yeah, so definitely when I was very young, probably about 10 or 11, definitely before I started high school. And at that time, there was no internet. I mean, it existed, but not in my house at the time. So I got books from the library that were printed out basic listings, and I manually copied them into the computer. And that's basically how I learned programming. So I didn't take a programming class until I was an 18-year-old in university.
Yeah. And that's exactly the same experience for me. I'm actually old enough that there was no internet. It was not my parents' fault. There was no internet.
And there are many people, I think, my age, like children of the 80s, that are now in their 40s that learned programming in that way. It's a very recognizable experience.
Yes. So this was basically self-study, inquiry-based, curiosity-driven, and that appealed self-motivated, and that appealed to what I think is a quite narrow demographic.
Yes.
And I guess one of the points that came as a surprise to certainly myself as a teacher, and also I guess to many other people, is that this doesn't actually work for most people.
Yes.
This is not a good way of teaching, in particular children, to program, but it's even true for grown-ups.
Yes. Yeah, because it requires, like, you need to be really certain that there's light on the other side of the tunnel, because it will be really hard. You'll run into lots of error messages. It'll be very complicated. You need a lot of, in my native language say, you need a lot of sitting flash.
Yes,
you need
flash.
Sit flash, yes. You need to be able to sit for a very long time. And if you're the type of kid that's like, I don't know if I like programming, right? I'm still like, what is programming? Let me just dip my toe into the water of programming, and then it's just, you have to type this, and you get so many error messages, and it's so confusing, it's not clear if it's going anywhere. A lot of kids will just drop out. They will not have the stamina because they don't know if it's going to be fun.
But it is, you and I know that, right? But certainly the wall that you run into as a child can be very frustrating. And I guess it doesn't really make a difference whether you're 10 or 21 when you want to learn this, because this is a hard thing to learn. Programming is not much easier than playing the violin or running 10 kilometers in under 50 minutes or many other things that are learnable, but where there's some pushback or tension in the beginning.
Yeah, and I think the interesting thing about programming is you have to learn a few things at the same time. So you have to learn syntax, but you also have to learn programming concepts, like what is a condition or what is a variable. And you have to learn how to combine the concepts, so how to create a problem-solving strategy. And even with small programs, you at least need to do both syntax and concepts. And very soon, you also need to do a little bit of problem-solving, program planning, or strategy finding.
And this is interestingly different than running fast or long or playing the violin even.
I think so, yes.
And you have a current project about a programming language target exactly that. Maybe we can get back to that, because I think that does many things right, in particular teaching because of the learning curve.
Yes.
Right? Maybe to phrase this in computer games terminology, there is no tutorial mode for programming, right? You have to do many quite difficult things at the same time.
At the same time, exactly.
And the progression is not. We haven't really thought about the progression very much so far.
And I think this is why it's different from, for example, playing the violin. Like, I don't play the violin, so my understanding, I played piano and saxophone, so my understanding of playing instruments is there are a few things to learn. Like, you have to place your fingers in a certain way, you have to have a few chords, but you don't need to figure out like what to do, because you'll have a teacher. Most likely you're not learning music by yourself. You'll have sheet music that you can read. You have music that you can listen to. So you do have to have concepts like chords and syntax as in finger placement, but at least there's one element of, okay, but how do I do this is absent unless you're maybe composing music.
Okay, but so to stay in the analogy which I'm just making up, then this would correspond to teaching children to read the music, to understand the notational system, and put the fingers in the right place, and interact with the other players, and dress nicely and so on for a concert, all at the same time.
And invent basically new music.
Oh yeah, by the way, find music, and also have, we also really want you to have fun now. Yes.
Yeah, no, have fun. Don't forget to smile.
Yes, exactly. Smile and be creative.
Yes.
So I think many of the things that make programming hard for children are exactly the same things that make programming hard
for any beginner. I don't think there's necessarily a difference.
Even though we are learning creatures, so there are many things that we learn for free, like our natural language is typically learned for free. But if I had to sit down and learn Dutch now, that would be difficult, and French would be even harder, and Chinese would be impossible. So programming is difficult, but it's doable and learnable. But one of the things, so your wonderful book explains many of the things that makes programming difficult. And some of these pages I just read and said, oh, that was interesting. And in other pages I said, if only somebody had told me this before.
Yes,
right?
This is why I wrote the book.
Yes.
Like, I learned so many things about learning. And then I thought, why don't I know these things? Like, why didn't I know these things? If you take a bachelor or master's degree in computer science, the professors will tell you, oh, but you will learn many programming languages in your life. You have to keep learning. But no one teaches you how to actually keep learning, right? They just assume if you know one programming language, you will magically also know all the other ones, and you don't know how to do it.
So just translating from one programming language to another is difficult, and then there will be many misunderstandings that you can avoid by being aware of this. But let's start with the first step of getting from no programming language to some programming language, right? So what is sort of the what are the things that make programming hard? This is a big question, but maybe you can.
Yeah, so I sort of think, like we discussed this earlier a little bit, that it is multiple things at the same time. That is one thing that is difficult about it. What is also very difficult, I think, is the curse of knowledge. Like, if you know something, then you immediately forget how hard it is that you've learned the thing. So I think
the teacher is certainly cursed with that.
Yes. Many teachers will say, oh, syntax doesn't matter. Oh, it doesn't matter if you learn Java or Python because it's about the concepts and about problem solving. The syntax doesn't matter. But at the same time, so this is your one teacher, the teacher. You also have your compiler, which is in a sense also a teacher. The compiler does not say syntax is irrelevant.
No, the compiler is very strict about that.
Missing semicolon, an expected end of file. So the fact that something like learning syntax is hard, but then all the professionals, the teachers, the professors say that something is not hard, creates like this brain melt.
Yeah, so I happen to think that syntax is really hard, but I also enjoy learning new programming languages.
Yeah.
So I think also most teachers are disabused of this notion of falsely thinking that syntax is hard when they start teaching. Because certainly when they interact with students, they will see that 90% of the interaction in the beginning is really about the semicolons and the curly brackets and why is it one and a two equality signs.
But then in my experience and understanding, professors then will not say, oh, but this is an understandable difficulty. Don't worry about it. With a little bit of practice, this syntax too will come. They will keep insisting that it's not so very important. That is not, the course is not about syntax. Whereas for many students, learners at high school, elementary school, or university level, it is about syntax. I think that is like a core
It's
issue.
like learning Arabic. The letters are in the way, and once if you talk to an Arabic speaker, they don't even see them. Same is true for Chinese. So your book is full with these observations about what is hard. It's also super useful because you give tips what you can do about it. What should I? So pretend I want to learn some new obscure language like Rust. What should I do?
Yeah, so definitely you should practice syntax, and especially as someone that is professional or proficient already in other languages, you might think, I'll read through it, but that doesn't get you far. So you should actually memorize a little bit of syntax just so it gets easier to read stuff and be really aware about differences between languages. So many of the things you know now will not work or will work in a slightly different way in Rust. So
dangerously almost work.
Dangerously similar, both in terms of syntax and concepts.
So let's do Cognitive Science 101. How can I learn to memorize? One approach to that would be just learning by doing. Just sit down, Tor and write 5,000 lines of Rust?
Yeah, this is doable, but probably not the most effective way. So there are ways that are more effective, like flashcards that you might know from learning a second or third natural language. On one side you put Danish, and on the other side you put French, and then you pick up a word and you're like, do I know this word? I think so, and then you flip it around.
So what, for programming language, it would be curly brackets on one side and nothing on the other if it's from Java to Python? Or
Yes, well, you could have a snippet with a little bit of indentation. And then the key there is called retrieval practice. So the thing is, you should look at the code snippet and then try to retrieve from memory what's on the other side.
Yeah.
You shouldn't just like read your notes, because what we know from cognitive science is trying to remember something will strengthen your memory of the thing. It's like if you have a jungle and the first day you find your way to the jungle and then you like, oh, this is where I have to stay tonight. Then there's a little bit of flattened grass. This is how your memory works.
Yes.
If the next day you go over the path and the next day you go over the path again, in a while it will be very easy for someone to find your little jungle house. This is your memory also. Every time you try to remember something, you flatten the grass, you get rid of the weeds.
so why don't I just turn over the page? Why don't I just flip over the flashcard?
Yes, because the little jungle pad in your memory is only created when you try to retrieve a memory from your long-term
So
memory.
the tension is important.
Yes,
The effort
the
has to be
trying is
slightly
important.
effortful.
Even
Yeah.
if you then don't remember, still trying to remember, this is how you strengthen your memory. And this is interesting because it goes somewhat contrary to what programmers sometimes think. Like, oh, I don't have to memorize anything because I can simply look it up on Google. If you look something up and you don't actively try to remember, this jungle path will never appear, and you will consistently be looking it up all the time.
So let me just give the false claim, and then you can push back. I can actually look it up. Right?
Yes.
I forget bash syntax all the time, and I look it up. And what's the problem with that?
That you will never remember it. And
Yes.
this is maybe not important for something you do once a year, right?
Bash.
But if you do something very often, looking it up just takes a lot of energy. And then specifically, if you look it up on the internet, then what happens to me is you open another browser tab, you find your search, and they're like, oh, wait, I have an email, I have a notification on LinkedIn.
Cat
right?
picture.
Cat pictures.
Yeah.
And so specifically in the sea of internet distraction, even leaving your IDE to look something up, it takes time. There was interesting research by Chris Parnan on this. Going out of your task and coming back, being interrupted by something like a phone call or a colleague or looking something up, it takes about 15 minutes for you to get back on your feet. This is the flow that developers really like. It disturbs your flow if you have to do another task and then come back.
There's this beautiful comic strip about this, where you see a thought bubble in a programmer's brain slowly
Yes.
building up a intricate structure of the flow of a program or variables or whatever it is, and then somebody else comes in and asks an unimportant question, and then poof, it poofs.
Yes.
Yeah.
This also happens if you look something up. Then of course you will forget what did I need the bash for.
Yeah.
And then of course again, if you do this occasionally, it's not so very important. But if you're in the middle of programming and you have to leave your IDE to look something up, it's just very disruptive for your working memory.
Yeah, that's another. I mean, distraction-free environments is also a really, really important way
Yes.
of getting focus. I want to talk about cognitive load a bit more later.
Yes.
Let's just finish the. I guess this is 19th century science. These first experiments in memorization, right?
Yes,
1880s or something.
Yes, very old.
Yeah.
These, where researchers were trying to get kids to memorize poems. And I was like, why doesn't this work? Yeah, it's very old science.
Yeah, and some German dude who I guess trained himself to memorize long sequences of words,
Yes.
and then timed himself in how long it took to retrieve them, and
Yes.
actually had very impressive data on that for a 10-year-long
And there's also
research
it's
project.
also in the book. This dude that forced his wife and 2 children to learn French words, and
Yes.
then he kept quizzing them
Yes,
about
yes.
what they would still
Wonderful
remember.
dad, but he did it for science.
Yes, exactly. Well, ethics committees nowadays probably wouldn't
Yeah, you can only do that with PhD students now.
favorably
Yes.
on testing on your own kids.
No. Well, we learned something. We learned
Yes,
something
that's
about
good.
programming.
It was for science, yes.
It was worth doing. So let's get back to cognitive load, where we just opened that, because there are many things that are difficult in learning to program, and you have this these three different bullet points, actually, long-term, short-term, working memory.
Yes.
So that helped me a lot to understand why is something difficult, right?
Yes.
And just understand. So when I try to learn something, and sometimes it's difficult, and so my mindset is that I actually think this is slightly great because it's difficult. So I'm motivated by being
slightly
yes. But not everybody is like that, and many people have better things to do with their time. But just understanding why is it difficult helps a lot. So you have this 1, 2, 3 model of long-term, short-term, and working memory.
Yes.
So explain.
Yes, so this is also for me, that's not my model, right? This already exists for a very long time. But for me, it was so helpful in understanding why something is hard. And for example, if you imagine a programming language that you don't know, like let's say Rust, you don't know Rust. Imagine if you look at a programming language that you don't know, you might think, even as an experienced person, oh no, I can never learn this. This is too hard. But then if you know this is just my long-term memory lacking knowledge, like it's not that you are not able to understand. It's just a thing you don't know yet. Like you might not know Arabic or Chinese or something. Whereas in another situation, you might look at a program in a programming language that you're familiar with, but it's just a very badly designed program and lots of like cryptic variable names and stuff that gets passed around. Then it's not a matter of I don't know the syntax, I don't know this concept yet. Then it's a matter of, oh, my brain needs to work really hard to figure out what's going wrong.
So the difference is between reading very well-designed code in APL and crazy code in Python, which I know by heart.
Yes.
And these are different. Exactly. These are difficult for different reasons.
Yes, and it helps. At least it helped me so much to like be softer to me as a person. Because it wasn't like, oh, I will never be able to do this. It's like, this is hard, and I understand why, because I lack the understanding of whatever's going on for a familiar language in an unfamiliar part of code. And I lack the knowledge. Like lacking understanding and lacking knowledge are different things.
Yeah, so that's a lovely perspective to understand, to be kind to yourself and also to others.
And to others, that too.
And so it's understanding that the admission of ignorance is actually some way of being kind to yourself and not holding yourself up to
but
impossible
at the same time,
standards.
It's also actionable, right?
Yeah, exactly.
Because if
kindness is actionable.
Yeah, if I see, but I just don't, wait, this is one syntax, I've never seen this. There's a path now, I can look it up. And then the book has a lot of strategies also for if you have to read complicated codes, you know the syntax, you know the concepts, but you don't know what's going on. There's a lot of strategies that you can use to help you support your working memory. So if you know what type of cognitive issues you are encountering, then the book also helps you figuring out how to get out of the hole.
So not knowing the APL syntax, which is, by the way, crazy, and not knowing the specific Python library, I don't know, PyTorch, these are the same kind of lack of knowledge, right? This is long-term memory
the same category, of course, they're different from each other, but they're the same category. There is a concept or syntax that you don't know.
Which I could remedy by just sitting down and working through that.
Yes.
Area.
And if you suspect you will use it more often, memorizing it, so next time you encounter it, it will be easier for you to read.
And the skill set there is both actually just using it. It's typically I need to know, I stumble over a new library which I need because I have reason to believe that this solves the task I'm doing right now. I don't want to write the parser for blah.
Yes, I want to do it quickly with someone else's code. Yes.
So I just plug it in and it almost works, and then I have to learn a bit more.
Yeah.
So that is self-driven and motivating, and there's a clear goal, and it's problem-driven, so it's not stupid to do that. But if I have to use this more and more, then a more systematic approach would be at least as useful. Actually, reading the documentation. And less frustrating.
Yes.
Yeah, that's a good point. So that is long-term memory, which we can do something about. And the others are short-term memory and working memory.
Yes.
Why are these not the same?
So it's an open debate whether they're the same or not. There's like a little footnote in the book. But for me, short-term memory is really when you remember something. For example, you look something up in Google, and you have to take that and move it to your IDE, right? You have to remember it.
A phone number or
a code snippet, or like a specific order of parameters in a function call. You look it up in the docs, and you go back to your code.
Good example.
And that's really remembering something. Whereas your working memory is more like the processor of your brain, where you're taking what's in your short-term memory and doing something with it, reasoning about it, but they are very related to each other.
I can do more about the latter, right? The code that is confusing to me because it's, I don't know, a tree traversal or an obscure way of computing the Fibonacci numbers by iterated matrix multiplication or a recursive function call. That is not short-term memory because the code is right there.
Yes, but you have to do something with it. Like I have this example in the book of a little bit of basic code where you will understand all the concepts if you're like a regular programmer, but then now you have to. I usually often have my finger, like if I have code and I am tempted to use my finger to point at things, this is when my working memory is activated. I'm like, what is this parameter?
Why do I divide by
two? Right?
Why do I divide by 2 here and not there?
Exactly. So this is your working memory. You have to figure out what's going on, and it takes cognitive energy to do this.
So how do I increase the working memory?
This is not possible.
So what do? I just give up when I see code I don't understand? Or
sometimes, yes, but there are things you can do. So your working memory is very limited. Research shows that just 2 to 4 elements fit in your working memory, very limited. But then if you have a sheet of paper next to you, this is almost unlimited.
Yeah.
So what you can do if you feel your working memory get full is offload some of your working memory to a piece of paper, like draw a diagram or a graph, try to offload something. A debugger can also really help if you're figuring out what is the value of this. You can step through the code, and then every step is small, so every step might fit in your working memory. And then you can do 2 steps and 4 steps. And manipulating the code, refactoring for understandability is also something that can help.
So even kind of Wild West debugging, which I do a lot with just a bunch of print statements, that would qualify?
That can help, yes. Of course, you have to keep tabs on, am I making progress or am I just running this code 7 times and have I not learned a thing?
Yeah.
And sometimes also when you understand 2 or 3 lines in a row, you can say, okay, this I understand. I can, for example, make a function call here with just these 3 lines and then read the rest. This is what I call a cognitive refactoring.
Yeah.
I'm refactoring the code because the functionality stays the same, but I'm not necessarily doing it to commit this to the repository. I'm doing it now temporarily to support my understanding.
Or actually rewriting the code, or just in your brain?
Actually rewriting the code. Sometimes
like
it can
changing
also
the for loop to a list comprehension, if that's
example,
natural for you.
Or if you have 3 lines, just do extract method and put this in a method. Oh, I've understood what those 3 lines do. Maybe this is the initialization code. I just replace these 3 lines with initialize. And then I do not have to think about this. It doesn't fit my working memory now. I will just continue initialize. Okay, next few lines. And then maybe this is better, right? Maybe you will leave the code like this if you're finished understanding, but maybe also you just leave it like this. Or like simpler examples might be renaming a variable, adding a comment. All these things are cognitive refactorings. You're just making all the things that you have to put in your working memory smaller by offloading the part that you already understand to the paper or the IDE.
Yeah, I think that is one of the progressions I see with our students here at ITU, where we teach a lot of really smart people who have no programming experience. Programming, I can see when I walk through the hallways week after week, there's more and more paper to the right of the laptop. So in the first weeks, they sit with the laptops and stare at it and look quite frustrated. And then after 3 or 4 weeks, there will always be a piece of paper with some doodles on it. Just state diagrams, or what is the value of that variable, or what are the variables called. So that was like the first thing. Why is this hard? And a working taxonomy that you use actively with yourself to understand why things are hard and what you can do about it seems to be super useful because it makes stuff less frustrating.
Yes.
So other tips and tricks, and many of the tips and tricks are stuff that stodgy old programming teachers like me teach, but they actually work as like naming variables and classifying them into types. That was another insight that I was not aware of, that not all integer variables are the same, right?
Yes.
Integer variables can have very different roles, and we should have some terminology or taxonomy in putting these into different conceptual boxes.
Yeah,
I think you have
this.
12 of these boxes or
Yes,
something.
again, this is not my work, this is just work I report on in the book. Saija Niemi is a Finnish researcher that came up with this roles of variables framework that indeed says sometimes an integer is stepping through a list, like for I in range 1 to 10.
That's what he calls a counter or
This
a
is
walker.
what he calls a counter,
That
yes.
is a counter, yeah.
No, I think a stepper.
A stepper, yes,
stepper?
it's a stepper.
Yes. But sometimes an integer value might be an accumulator where you say sum is 0, and every iteration of the list you're adding the value into. So both are, for the compiler, both are the type integer, but from the perspective of especially the novice programmer, these are very, very different things.
Yeah.
And pointing out that they're different, giving a vocabulary for, look, this is a stepper. And this, I think, as an educator, this is such a valuable framework because you can ask a student, hey, that's I. Is that a stepper or is it an accumulator? And if they already don't know this, then it doesn't make sense for them to continue programming. Then they're just stuck in a way that they don't know yet.
Now, I found that super nice and for sort of trying to break down a program, which is just a bunch of text in the beginning,
yes.
Into these various roles, which are not types. That was interesting to me. So there's a tradition. We are almost at the Emacs versus Vim debate, which we will get to. But there's another religious debate here about naming variables with. There's this Hungarian method due to Simone.
Yes.
And you're slightly more open to the idea of prefixing the name of the variable, not with the type, but with the role.
With the role, yes.
Yeah.
I actually think this Hungarian notation does make some sense, specifically, again, for novice programmers. If you name a stepper, this helps in understanding, not just if you have to understand code by someone else, but also while you're problem solving. We might not lose track of what variable is used for what as experts, but a beginner might need this stuff to hold on to. So if they can offload some of their understanding of what the variable is doing into the name, this is going to be very helpful.
And that is interestingly different than one of the things that I'm always slightly annoyed with when I see novice programmers programming, that they have a variable that would be called the int.
Yes, yes.
And the int is a really bad name because you're just naming the variable by the type used to hold the variable.
And this is not giving you extra information because in most IDEs you can hover over the variable and it will tell you what the type is.
Yes.
So this is not storing extra information in your brain into your view, but saying this is a stepper or this is an accumulator value.
But still, this seems to be very easily accessible to a novice programmer to suddenly understand the whole world in terms of ints and strings.
Yes.
So when they try to solve the first program, all the variables will be called the int and then the other ints.
And this is so cool about the roles of variables framework that this author says 99% of all novice programs can be covered with these roles. So it's a really small and clear framework, but it does allow a beginner, this is now something I can find my footing.
Yeah, and accumulator and stepper are clearly better.
Yes.
And I think they're also accessible in a way that a really good variable name is not. Because I guess coming up with the really good variable name
is very hard.
Yes. Right?
And then experts, also teachers in their examples, are sometimes a little bit sloppy. All the counters might be called I, and all the accumulators might be S.
I'm a mathematician. What could be wrong with that? Yes.
Yeah,
variable names are, of course, X and Y and T.
That is not so clear for a beginner what the type is or what the role is.
Yeah.
So this framework is just very, very cool.
And this was called let's just get variable roles or what?
Roles of variables.
Roles of
and
variables,
the author is called Saija. It's a Finnish author.
So speaking of Finnish authors, you mentioned another Finnish author who has this amazing list of 162 different programming mistakes.
Yes, misconceptions.
Misconceptions, because there are things that are hard to learn, and there's stuff you have to learn, and it's still hard in the beginning, and you sort of become better and better at it. But and that is difficult. But there are other things that are hard to learn because you misunderstood something.
Yes. So this is called a misconception.
Yes.
And the other Finnish author is called Juha Sorva. And as part of his PhD thesis, that wasn't necessarily about misconceptions. He made this really nice list, like a literature survey of other papers that have not, where the student isn't confused, but they really misunderstand something. An example. You might think as a student coming from math that the equal sign is commutative.
Not only from math, right? This is what we tell them everywhere.
Yes. 2 plus 1 is 3. 3 is 2 plus 1.
Yes.
And now we're in the world of programming. So you see A is 5. You might think, I might also type 5 is A. Why not? Right?
Yeah, that's the and
makes
another
sense.
example is temperature equals base plus 12,
Yeah.
where you might falsely assume that means that from now on temperature will
This
always
is a
be
relationship.
base plus 12, and
Yes.
when somebody changes base, then temperature also
Yes.
changes.
And this is true in some programming languages, like in
Yes.
Excel.
Yes.
This would be true.
Yes.
So this is the situation where, from another field or sometimes from another programming language, students assume that something is true and it's not. And this is harder than just them being confused, because if they assume something is the case, they do not look up further information.
No, of course
because
not.
they think
Yeah.
they already know
And
it.
all learning is like that, right?
Yes.
All learning is finding these hooks that you can hang your intuition onto,
Yeah.
and as long as it works,
Yes.
you actually will stick to that.
And it can be very persistent.
Yes.
Specifically if it's not syntax based, where the compiler will tell you, hello, you have the wrong idea, buddy. This is not going to go well. Then if you, for example, run an interpreted language where only at the runtime you will realize your mistake, and the path between programming and figuring out your mistake is really long, you might not connect it with something you're very sure is not
then
incorrect.
at least you get 32 lines of completely obscure error message back.
Yes.
We will get back to that
That
also,
will
because
help.
we need to talk about Hedy in a moment. I like these misconceptions. So one of my I talk to novice programmers a lot. They're grown-ups, they're not kids, so they're able to sort of formulate what is wrong in a way that is more informative than kids. But it's just super satisfying for me to see all these learning moments. My favorite example is one of our super bright students who simply couldn't get past this particular exercise, which I thought was really easy. And we talked a lot, and there was growing tension until the student said, "Oh, can you have more than one if in a method?"
Yeah.
And of course you can. How would you design a programming language that disallowed? It's much easier to have a syntax that allows more than one if.
Yes.
And I looked through the textbook, and yes, correctly, all methods in that textbook so far had exactly one if statement or a while statement, but never an if inside an if or an if after an if.
Yeah, one of my favorite examples is functions. Very often, functions use in the definition the same variable name as when calling it.
Oh, yeah.
Yes.
Yeah.
So you have temperature is 5, and then the method is, I don't know, maximum or something.
Convert to
and
Fahrenheit.
you put in the temperature, and then convert to Fahrenheit. It's a better example. Convert temperature, and then in the function definition, it's also called temperature.
Of course.
And then students think this has to be the case.
Of course. Yes.
And then they never disconnect these things as being two distinct variables. And then they might think that changing the temperature in the function means it's also changed at the call site.
Yeah, and it's very hard to see. So this is some kind of false induction.
Yes.
A wrong mental model has been built that is consistent
with the examples they've been
with all
shown.
the examples.
Yes.
So and it's hard to understand that somebody could even misunderstand this.
Yes.
And then as soon as this example with the if statements became clear, then I could sort of see all the puzzle pieces fall into place.
Yes.
And from then on, it was just full speed ahead.
Yeah. And this reminds you as an educator to vary your examples so that you also have two ifs or a for and a if or whatever.
Yeah, and always also be aware of the fact, as an educator, my own brain is conspiring against me by only showing me positive examples. Right?
Yes.
We all suffer from confirmation bias. Yes. All our brains try to preserve our self-image. So I will only find examples that sort of flatter my preconceptions and the positive examples of the models.
Exactly, and the rest you'll just not remember.
Yes. Yeah.
Yeah.
So brains suck, but that's just part of life and part of learning. I also like the example with the while loop, right? It seems so a while loop has this condition after it, and then there's a block of code, and the block of code is evaluated while the condition is true, and that's actually how we tell people, but it's a lie. The condition is only evaluated at the end of the block of code.
Yes.
And the program does not jump out of the while loop when the condition is false.
And some kids, or learners, can also be students. They think that if you invalidate the condition in the middle of the body, it makes so much sense.
Of course. Why don't we have that construction?
Yes. It's also like in natural language. You will say to me, we will sit here while the podcast is going.
Yes.
It's not that every 5 minutes I'm like, is the podcast still going? Oh, we have to stay. No, immediately when it ends, we could go.
So that's hard for a different reason. That's hard because it's a misconception, not because there's a cognitive load on you. So cognition I'm somewhat frustrated that there seems to be so little research. So your book covers a lot of the research in cognitive science about programming, but I would expect cognitive scientists to be all over this because there's so many interesting questions about learning and understanding that could be studied on programmers.
Yes.
But there seems to be very little research on this.
Yeah, so I think it is getting better. So compared to 10 years ago when I started to work on the book a little bit, more and more people are getting into this. But I think maybe, so I don't know why, right? But I can hypothesize, I think it has to do something with computer science coming out of math. And being very much tied to research methods from mathematics and research philosophy from mathematics. I think it took us a while as a field to figure out, hey, we can learn something from the social sciences. Like famous Dutch computer scientist Edgar Dijkstra he wrote these sort of blog posts avant la lettre that he wrote and then mailed to everyone.
Yes.
He has this flaming piece about that social scientists should not kid themselves into thinking they have anything to add to the field of computer science. And I don't think it was just him vocalizing his own opinion. I think that at the time was sort of seen by many people that the field of computer science is just applied math, and why would social sciences help math? So I suspect that it just took us a while to figure out this is a field about people and not a field about symbols only.
It is both, right? It is about,
both.
and
Yeah,
that's what makes
both,
it hard also, because we kind of pretend it's math and we kind of pretend it's language, and it's both and neither.
But specifically software engineering, where
Yes.
not one person is writing a tiny algorithm that can be proven correctly, but a bunch of people across generations, across continents are building something together.
So
That is
now
a
you're
people-
telling me that
people thing.
I'm a competitive programmer. Now you're telling me that programming is not about writing 12 lines of code that will be run exactly once and then never again back to.
Yeah, that is programming, but there's
Yes.
more programming
Yes.
that also needs to be researched.
Yeah, and in particular when you interact in a larger programming project, which is
Yes.
a super cool and satisfying thing
Yeah.
to do, whether or not it's with sort of paired up with somebody you're in the room with, or you're part of an open source project.
Yeah.
That's a huge learning experience, because it's a different skill set
Yes.
related to programming, but not identical to programming. And it's also a lot. So people like me, so most of the code I interact with is code I write myself, which I find is good fun, but that is not typically what a programmer spends most of their time on.
No. And then sadly, if you look at many university curricula, then what they do is exactly writing code themselves
I'm
alone.
guilty of that.
Me
of
too,
course.
me too,
Yes.
yeah. All of us are. So it's really hard for them also. Very often my friends in industry say, well, these kids that come from your program, Felienne, they do not know anything. They don't know version control and testing. Right? It's no, that's not the stuff we teach them. At least not enough. A lot of that you still have to learn after.
It is very so. I design educations, and this is actually it's a hard problem for an education to teach, to find teachers that are academically accredited to teach, for instance, version control.
Yeah.
Right? Because version control is not an academic discipline like, I don't know, data structures is. So it's difficult to become a professor of version control and have an active research agenda.
Unless you're building the version control algorithms, and there's probably some research there, but that is not how do you fix a merge conflict in Git.
No. So it is actually structurally difficult for an education to attract teachers that are good at this thing. I think here at ITU we're really, really good at that, right? And it's hard enough to be still fun and challenging for students, but finding these people who are really good at DevOps or software development,
or full stack.
It's they are hard to find. Also, industry, of course, has completely different remuneration frameworks for them, and they actually have very satisfying jobs. But getting them through the tenure process is not easy.
No, I get that.
But I think we're doing some things right here, and it's a lot of fun. But software development is really about reading code as much as it is about writing
definitely,
code.
Yes,
So,
and also about learning about reading will also help you make more readable code.
Yes, because I basically write for myself, and I'm good enough friends with me that I want to be kind to myself. So I try to write code that I can understand later on.
Yeah, that's nice.
But that I'm completely egoistic about that. But interacting with others is really is a social process, and you interact, and the substrate along which you interact with other people in software development is code, which you have to read and so you write not only for the compiler, the dreaded compiler again, you also write for the
other people. And they might have greatly varying backgrounds. If you're in a professional context, then you are friendly to yourself, but also you share prior knowledge with yourself.
Yes.
But someone in a company or in an open source project also, maybe someone comes in and this programming language they have never seen, or they're not proficient enough, or they know the programming language, but all of the concepts, like I write a parser, like people might know Python, but if you've never written a parser, then reading parsing code in Python is still very hard. So you also must think of who is the expected audience of this, and what if they don't know what a parse tree is?
Yeah, or this particular trick, this particular algorithmic trick.
This library, all these things.
Yeah, I do some work with high school kids in competitive programming who write extremely obscure C++ code and clearly address other people who have the same background. So it will be sort of almost ununderstandable that this is sort of the convexity trick in dynamic programming, and there are 15 people on the planet who understand this. And there's a lot of learning for them to do, to write stuff that is useful to other people than just solving this particular very tricky problem. But so getting back to naming conventions, and maybe that could be a segue into your current project with Hedy. So your current project is not only a programming language, but also basically a didactical project, I guess. It's an unramping to a text
trajectory, we might say.
Trajectory, very nice way. A trajectory to an the other we will get back to trajectory, very nice word later. The other word that I had to look up was notional. So a notional machine. Can we, before we go to Hedy, can we talk about notional machines?
Of course, yes.
So is that just a machine model? So explain the word notional machine.
Yes. So notional has to do with notion.
Yep.
And a notional machine is, if you think about what the program is doing, what is the machine that you're thinking of? For example, if you have assignments, you might think, oh, x is 5, and the next line is I is x plus 3. You might think of substitution. You're like, oh, this 5, it goes in place of the x. And this is the way you might think that the machine works. This is not how the machine actually works. Like, we don't think about memory and pushing stuff into registers. So the machine you're thinking of is a machine that takes the 5 and puts it in place of the x.
Right.
This is what you imagine the machine to do, which is an abstraction over what the machine actually does. This is a notional machine.
So the von Neumann model is a notional machine.
Yes, but it's already a very complicated one.
Right, so having understanding variables as boxes that I put values in.
Yes, this is more a learner's mental model, where you say, oh, if you store a variable into the computer, you take this 5, you have a box that's called x, and then you take this 5 and you put it into the box. This is also a notional machine. This is how
that
you
already
think.
does a lot, right? That avoids many misunderstandings, like x equals 5 being an equation.
Yes.
Right?
Yes.
This tells us that 5 goes into the x box.
Yeah.
So I think you have two of these different ways of understanding what x equals 5. I mean, there's the box notion and there's the label notion.
Yes, exactly. Well, there are many different ways, but there's two sort of competing ways that we did some research into. Because the problem with a box is that students might think multiple values go into the box. So you might have x equals or becomes 10 and then x becomes 5. They might think, oh, I have a box, 10 and then 5. What is in the box? Oh, it is 15, right?
So your box became a set.
Yes. It's big. Many values can go in.
Oh, okay, and that gets even worse if your programming language has set x equals 5, has the word set in it as a
set in it, yes. Or students might also think that the first value is still there. So it's 10 and then 5 goes on top.
And then
but if I would want to, I could still go back to the... Yes. They don't know what a stack is, but they know that this is a mental model.
It's a very natural thing.
So the problem with a box, we found in our research that a box is easy. It's a good way to explain to absolute beginners. But once you have consecutive assignments to the same variable, then the box gets more confusing than it is helpful.
So what's the alternative to the box? Just a box that can only hold one value?
Yes,
Or?
so that's sort of a hack, right? So we have this nice videos where like, look, this value is exactly the size of the box, or the box has a shredder and the old value goes out at the bottom, but then it becomes too complicated. So you also have the label, which like a sticker, you say, a variable is like a name tag you put on yourself. Hey, I'm Felienne, there's one name sticker, and I can put my sticker on something else. This is not so natural, but it does remove the confusion that there's just one sticker and it only attaches to one value and not to two.
So here I need then all the integers to be, there's a line of integers and I put labels on some of them.
Yes, exactly. Yes. I have my temperature sticker and I can place the temperature sticker on the value 20.
On 20, and I can put another sticker on the same value.
Yes, but the sticker is only attached to one value. I have to peel it off and stick it on another value.
Okay.
If I want it to move.
And I can see, so some of the things that become very confusing early on are multiple references or changing the value of a list that you point to with two variables.
Yes. And the sticker helps, but it's also more confusing because a box is very intuitive.
Oh, I can put a sticker on the sticker. I can,
Yes.
okay, again, this is a way of using some kind of taxonomy to make explicit and to make explicit a mental model.
Yes.
And this is a conceptual model.
Yes.
And notional here is just a different word for conceptual. Or am I?
Yeah, or mental, right? Because notion is like the notion of. So it could also be a mental machine, but there's another sort of competing concept that's a mental model, which is not exactly the same. This is just the concept that computer science education settled on.
And I guess I'm just frustrated because my native languages don't have a pendant to notion, or do they? I have concept in my other language, and I have mental.
Yes.
But I don't have notion.
No, I don't either in my language.
There's no. Is it Begriff in German?
Yeah, begrip. Yeah.
Ah. But that's also just concept. Yeah.
Yes, it can also be understanding. So that's more confusing because it can be both. It can mean concept. It can also mean understanding.
The boxes I can stack on top of each other, so that I like, because
so
that gives me an array.
Yeah, so this points to some notional machines can be nicely composable.
Right.
Some of them really work together well, and others are in conflict with each other.
We lost, I got off the trajectory. Yes, let's get back on the trajectory and try to end with Hedy, because so now we go away from teaching both yourself as a working programmer. So most of what we said here is useful both if you want to learn to program, but also if you're already
a professional,
pretty good programmer, because the naming conventions or taxonomies or understanding that moving from one language to the other is not really only about syntax.
Yes.
Of course, when I moved from a C-based language to Python, I just wrote basically C and Python for a long time, right?
Yes.
Still had lots of iterations.
One of my best friends always says you can write Java in any language.
Yes, of course I can. Yes. And now I really love Python. I'm sort of getting away from I still thought very much in static types.
Yeah.
And I didn't, the list comprehensions seemed alien to me. But now it gets better and clearer, and I really like this. And now it would miss it from another language, I guess. But let's get back to actually teaching kids programming.
Yes.
Because many countries need to do some work, and we don't know how to do this. Most countries want to do this.
Yes.
Most countries have plans of teaching children to program, and maybe that's a good idea. I like it. I'm certainly on board with that, but it seems to be difficult. And there are many ways for why this is difficult. Yes. I've been involved in this development now for, I think, 30 years in 2 different countries. And it's organizationally difficult, it's structurally difficult, it's also didactically difficult, because teaching programming is hard for the same for various reasons. Once it's programming itself is hard. Finding people who can teach programming and want to teach programming is also hard. But it still remains, and this is what the start of our conversation, that you need to do all these things at the same time.
Yes.
So, and there you
and
actually
that's
have
a problem. Yes, and there I have a solution.
There you have a solution.
I'm actually a teacher myself, not just in university, but also in high school. So I teach 12-year-olds programming. And this is when I really realized, oh no, this is hard. I didn't remember from when I was a kid that it was so hard.
So high school for you in the
Starts
Netherlands
at 12. Yes,
starts
it's
at
different
12.
from many other countries.
Yeah.
We start at 12 because we don't have middle school. So I created a programming language called Hedy that disconnects these things. So initially the syntax is really, really easy. You just have 3 keywords. It's just print and ask and echo. And then you don't need, for print, like in Python early days, you don't need brackets, but you also don't need quotation marks. You can just say print hello world, and then it works. So kids can get used to, oh, this is what programming is. Oh, it's a keyword, and there's the difference between a keyword and a string, and this is what the user interface looks like. There's a button, and this is how stuff works. We're like, okay.
But that's already a lot.
This is
right?
already a lot.
Yes.
Yes, this is already a lot. And then
But print would print.
print would print. Yes.
Oh, nice.
Yeah, so that's nice. And whatever is behind the print will be printed, even if it's whatever. So kids can get used to this is programming. And then we have 18 levels currently. Then in the next level, we say, okay, then now we add variables. Not only can you say print hello, you can say name is Felienne, print name. And then you do not have to have brackets or comma between arguments. You can even say name is Felienne, print hello name. And the hello is a string and the name is a variable name, but you still do not need quotation marks.
But this is already mildly insulting to me as a programmer.
I know,
Yes, and that's of course the point. That's why I phrase it like
Not
this.
like my point to insult programmers, but I see how that can accidentally happen.
It's a super good example of also explaining to me as a programmer, because I clearly feel resistance already now.
Yes.
But of course, this is the right way of doing it. I'm completely on board with your project. I think this is exactly how we should do it. But let me pretend to not like it.
Yes.
So let's do this again. So name is Felienne.
Print hello name.
And then the result of that is going to be hello Felienne.
Yes.
The implicit goal of this entire conversation is to say your name correctly as often as possible, because many people seem to get it wrong.
Yes, true. That's a nice side effect.
Yes. So how does now I'm speaking geek speak, how does the parser know which one is a variable and which one isn't?
Well, basically we just parse twice. Like we parse once, we figure out what the variables is, and then we parse again and we put the variable value in place of the variables.
So name is Felienne on line 1, and
Yes.
print my name is name.
Yes. This is a problem because that creates my Felienne is Felienne. Because all names will be replaced by the value of the variable.
And this is a problem you want to have, because
Yes.
now on level 2 already we explain why there are variables and why there are quotation marks,
Yes.
and why a programmer wants, for expressiveness,
Yes.
to be able to tell the system that sometimes it's a variable and sometimes it's
So you run into an issue.
It's a literal.
So it has multiple benefits, this gradual system. First, the cognitive load remains low because you don't have to do many things at once. And also you sort of take kids by the hand, like, look, this is why we have syntax. Early on when I was teaching, kids would say, teacher, why do quotation marks go there? Or to say, just do it. Don't think about it.
Well, that's just public static void main string brackets args just has to be there. It's a magic invocation, otherwise your Java program won't run.
Yes. So then gradually we build up, and then the final level of Hedy, which is level 18, is a subset of Python. So it's really, we take them by the hand and we show them concepts and syntax, slowly ramp up the volume until it's just Python.
So you have a family of less and less lenient and more precise or fragile syntaxes and semantics
Yes.
that end up being
Python. Yes.
Or a subset of
A
Python.
subset of Python. We don't do objects. We do for loops, while loops, functions, lists, so basically all the stuff, but not objects.
Yeah, that's one thing that I love Python also as in. So why wouldn't I just advocate using Python as an introductory programming language? One thing is, of course, the thing you have with all languages, that the error messages are just evil.
Although they are getting somewhat better.
Very good people. Very good people are doing very good work on Python, right? But it's just super frustrating for a normal person to read that.
True.
But the other reason is that one of the, for me, most natural concepts in programming, repetition to a fixed bound, in Python requires somebody to understand objects, lazy object evaluation or something, right? Because in order to iterate from 1 to n, or from 0 to n minus 1, which for some reason we think is more natural, requires me to make a range object.
Yes.
And then have I iterate over that. So just to print the first 100 integers.
Yes, this is so frustrating. This is also what I found when I was teaching. You know, a 10-year-old wants to do 1 to 100. It's quite a boring program. Yeah. And then you have to do for I in range. It's really a weird word.
Yeah, which is an object. And then you made an iterator over that. For a professional programmer, that's completely clear.
That's already, it's so many things.
Yeah. So Hedy is both a progression of programming languages that gradually introduces more and more precise syntax, and that's not the right way of saying it.
No, I think it's okay.
Print my name is name. Okay, it's still okay. It's very okay. So it's well defined what it does on every level.
Yes.
That must have been really hard.
Yes. Yeah, that's like the fun stuff about this offending program is of course that for kids it's sort of natural, but you can imagine like the work that goes into figuring out parsing vague stuff, making sure that it actually runs, and allowing all sorts of things that we do not want to allow for obvious reasons.
So, and you figured this out by introspection or by observing learners, I guess.
Yes, right? Yes. So initially I had the same trajectory in Python, and then all the kids were struggling. Oh, not all the kids, but most of the kids were struggling. And then I thought, well, you know, I see this issue with kids in my class, and also I know compilers. Could I not build a small prototype of a few levels to just see how this would work together? Mm-hmm. And then it became a thing. Mm-hmm.
I'm super interested about the process now of building this. Are there things where you changed your mind? Like has level 15 changed from something else to something else?
Yes, definitely. So a few things that we changed. For loops. For loops are really, 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 really hard. Initially we did do for I. What was our initial syntax? I think we just did for I is 1 to 10 or something. So we started with numbers. This was way too hard. So what we have now is we put this, in Python you can also do a for loop over a list. So you can do monkey, banana, tree.
For X in monkey, banana,
for
tree?
For things in, yes. So you create a list. Animals is a list of animals, and then you do for animal in animals. So first we have them explicitly create a list and loop over the elements in the list before we make that list into a numeric list. So this is one of the changes that we added.
This is a really, I'm learning while I speak here. So this is a really good point that cognitively, the idea of iterating over a list seems to be available to almost everyone.
Yes.
But if you look at the history of programming languages, that came very late.
Yes, exactly. So I sort of thought of that in the history of programming. Of course you do numbers first, and then you do something more complex that is a list. But naturally, we have all these examples like students in my class, Anna and Bjorn and Annifried, for kids in class, print hello kid. So iterating over an explicit list with things is a lot easier. So this is just like one of the changes that we made to make it easier, to make it more normal, like to make it closer to
So how do we get to the, ask number, and now I want to print out number many things. I want to print 1, 2, 3 up to number.
Yeah, so that is only available once you have the numbers, once you have for I in range 1 to 5. So that it takes a while in the level trajectory before you can do this.
So the range object is a thing, or it just produces a list?
It produces a list.
It produces a list. That seems to be the right way of doing it.
Yeah, I think so too.
Very cool. Okay, I have to look even more into that. I really love this project. The other thing that Hedy does right, I think, and that's even more contentious, is that it's in Dutch.
Yes, and Danish,
and
and French,
Danish,
and Spanish,
yes.
and Chinese, and Japanese, and Arabic, and
I guess this can get us back to the naming things right thing. But talk to me about that. Why do I have to write then or whatever it is in Dutch for if?
Als. You don't have to, you can. Basically because I asked kids. So I did a user study early on with kids in my school where I said, well, friends, this is what I built. What do you all think I should add? And they were like, yeah, Dutch keywords. I was like, why, right? Because I imagine Danish teenagers, Dutch kids are really proficient in English. So I was like, why? And they were like, why not? Like, why does this system require me to learn English words? It isn't necessary. And initially, I will admit this, on video, I was very skeptical. I thought, it's just 5 words. Come on, kids, don't be lazy. But then once we added Dutch, other people started to add different languages because the Hedy is open source. So we got German and French and Spanish, and it got less and less similar to English.
Yes.
And then we got Greek and Hindi and Bengali and Chinese. And then I thought, wow, if your first language is Bengali, of course, print is really hard. Like, imagine a teacher in India. Well, we do print, and it starts with P, and kids will be like, what is a P? Right?
Oh, that's sort of level 3 away from But,
yes,
but just,
where is the P on my keyboard?
But just the first step of switching languages between. So even if as a programmer, I would agree with myself that I want my variable names to be Danish. So I don't have temperature, I have temperature.
Yeah, makes sense.
But then I have to switch languages all the time because the while loop still says while.
Yes, exactly. Yes, and comments. You might also do comments in your natural language, in your own native language. Yes,
example. Of course, yes.
Because you think probably in your own language, and even in industry, if you're not programming for only you, if you work in a Dutch bank, then the whole jargon of the company will be Dutch words. Dutch concepts that aren't so easily translatable because maybe they come from an exact Dutch law. Like we have a deduction on rent on a mortgage. It's like a specific word, hypotheekrenteaftrek, which has a very specific meaning. There's not a translation. So you are programming in your own language. So then I thought, I was very skeptical, but I thought technically as a nerd, it's an interesting challenge to build it. And once we build it, this was an example of if you build it, they will come. We now support 47 different languages.
Yeah. So, I would be immediately on the side of the kids there.
Well done, you.
Because for me, I would take that with both hands. I observe the different tension. We can get back to that. But from the cognitive perspective, it seems to me obvious to me that of course it has to be in the native language, just because it reduces cognitive load.
Yes.
Right. So this is of course something we should do immediately.
Yes.
I insist on using Danish terminology when I talk about science, and there I can see the exact opposite reaction from my students. But they are, of course, now grown-ups and not kids.
Yes.
Because language has 2 different roles. Language is both used for communicating and enlightening and so on, but it's also used to delineate in groups. Right? Language is also a marker of status and belonging. And university students, they want the exact opposite. For them, it can't get sufficiently obscure. So I gave an introductory lecture on version control last spring, using, of course, which is natural for me, Danish terminology. And there was an angry student who sort of had the position that I was keeping secret from them the actual magic words.
Keeping them small. Keeping them stupid.
Yes, and not giving them the magic words that give access to this.
To literature, for example.
To literature, to the in-group of cognoscenti, of the elders who actually use the grown-up words. And it's super interesting to me to see this difference that children seem to want the cognitively useful concept because they use language for communication. But that's not completely true. When I was 12, we had a secret club with secret words that the other secret club didn't need to learn.
This might be still a Latin language Western bias, because we do get reports from Pakistan, Afghanistan, where they really like to use Hedy, even in universities, for 18-year-olds in Urdu. And this university professor emails me and says, I have never seen this level of engagement because it just lowers the threshold. So for us, Western languages, English is close enough that
certainly
it has an unlocking factor. Whereas definitely if your language is so far away, then you might think, oh, this English language word is cool, but you don't know how to type it, you don't know how to pronounce it. So it really is still far away.
This seems to be it's extra true for, say, Danish or Dutch, which are just part of the Anglosphere
Exactly,
in any other context.
I think
but
this
just
is
going
why,
to Germany or Poland or France, it's completely different.
This is why I think I didn't see it initially, because Dutch is just ugly English.
Right.
It is so similar
we are blind to
that I didn't see the difference.
It's morphologically similar, but it's also culturally similar because we watch Schwarzenegger movies in English.
Exactly. All these kids, they listen to English American music, right? So they're so exposed to all these words and the pronunciation.
Awesome. Yeah. So I think Hedy is just the right thing to do. It's just because not only does it sort of spread out this idea of learning to program to a much larger user base, it also does all the things right about learning the language. Even though it's gradual and you have to change things while you sort of, I guess, when you get from level 5 to level 6, you have to unlearn something that you learned. But if this is well motivated, I guess that's again normal. It's also how you learn an instrument, that in the beginning you play just one scale on the violin. And then in book 5, there will be a new scale.
And this is also often true for math, where you have these changing mental models. Like first you do addition and then you do subtraction, but you cannot go below 0. And the teacher will say, oh, we cannot go below 0. This is not possible.
Negative numbers.
After a while, they sort of unlock the curtain and like, oh, look, you can go below 0.
So this is a normal way of it's a normal way of learning.
Yes.
Consistent with how we normally learn.
Yeah.
Okay. You got several rows of your knitting done.
I did, yes.
Is this relaxing or focusing or?
It's mainly focusing, right? It's really nice. The research shows that it actually helps you concentrate, and otherwise I get very fiddly with my hands, which is just not nice on video and annoying for myself.
It's cognitively very different than you sitting with your phone. Also to me, right?
Yes.
It takes no attention.
I also do this while teaching, actually. If my students are working on a project, I also often are knitting. I'm knitting because if I go on my laptop to do email, I'm not accessible, right? They think they're disturbing me. If I do this, I can look around, but I'm not bored because I'm knitting. It's a perfect hobby. And then at the end of a boring meeting, if you are in a boring meeting, which sometimes happens, then at least you have half a sleeve at the end. So it's not time wasted.
Yes. So this was not time wasted for any of us. Thank you for this amazing way out of this conversation, because we're out of time. Felienne, thank you so much for coming. Thank you for coming to ITU in Copenhagen. Good luck with your sleeve. And to everybody else, thanks for attending. Bye.